Hi everyone, today we're going to be looking at the Arduino Uno Super Starter Kit LEDs. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So we will now be looking at the LEDs that we can wire and program using our Arduino Uno Super Starter Kit from Elegoo. So let's look at the components that we will be using in this kit. And the first one is a breadboard. Now, breadboards allow you to create prototype circuits without soldering connections, and this provides a quick and easy testing of your circuits. So breadboard holes are for placing wires or components for your connections. So if we look at our breadboard here, along the top, all of these are connected, and they're usually used for power. So plus 5 volt would be on the red, and the blue across the top here would be for ground or 0 volts DC. And the middle row of holes run vertically, and they're connected as well. So these are connected here, and there's a space in there that shows or indicates that it is a break in that connection, so that we can put components in here with a series of pins on each side and then connect them easily to our circuit. Now, although these breadboards are great for prototyping the circuit, but not in production, because they are a push fit, and the push fits temporarily. You can see with vibration or use, they'll come out. So in production, the components would usually be soldered in for a permanent connection. So the next component we're going to be looking at, obviously, would be our LEDs. And our LEDs, or light emitting diodes, are a semiconductor device that will show light when current passes through them. And the light is produced within the solid semiconductor material, so it'd be called a solid state lighting device. And what you can do is, if you look at the LED itself, we have two leads. One is the positive and one is the negative. And the negative, you'll see that the positive is always longer than the negative. As well as we can separate this, we can also see that on the negative side, where it goes actually into the body, part of the body will be squared off, or there'll be a flat spot indicating that is the negative lead. So two different ways of telling the polarity of this LED light. And they are only one way. And what you do is you would vary the amount of current going through that in order to make it shine brighter or have it dimmer. So that is LEDs. Next, we're going to have a resistor. Now, a resistor are used to restrict the flow of current in a circuit. So we will be using the resistors to limit the amount of flow of this current going to the LED, so that we get a brighter or dimmer amount of light from our LED. So resistors have a color code to determine their value, and we have 4 or 5 stripes of color code to determine the size of your resistor. So, and here is the color code, and here is at the 4. So if we took an example, we will be using a 220 ohm resistor. So 220, we'll have a red and a red for a second digit, and our third digit will actually be 0. So, or it'd be, the next one, there'll be a third digit, so that's be a multiplier. So it'd be actually 10. So 2 and times 10 is 220. And then our tolerance. A tolerance indicates what percent of accuracy we're going to have for that resistor when we put it in our circuit. So that is a resistor. And the main thing to see how these all relate would be Ohm's law. Now, Ohm's law is a very simple calculation. It's voltage equals current times resistance. And we actually have a online calculator that we can use here. So our voltage, in our case here, we're going to use 5 volt DC. Our current, we don't know, we're going to calculate that. And our resistance, We're going to put a 220 ohm resistor in there and we can hit calculate. What then happens is it shows us our current as 0.02272 or 22 milliamps of current, and our power is 0.11 of a watt, so it's a very small current, but this would be the maximum brightness that we can get from our LED light. And it gives you a little example here, and it shows you the steps in which we calculate the 5 volts divided by the 220. So this is why I like this online calculator here, because it actually shows you all the calculations that we have for this. And then it goes into a little more detail about Ohm's law and the power and how to get all of that information. So if we were to now look at wiring to our breadboard, what we'll see is, let's call this up our hardware. Here we go. So what you'll see is we have 3 LEDs located right here. They are red. And what we do is, if we look at our LED, put another one right here on our board. And the shorter lead here is our negative. So it will go into our blue line. That's all connected across the top. And then the other end of the LED is our positive, which goes into one of these pegs along the horizontal here. The other peg will go to one side of our resistor, and the other side of the resistor goes back to the red, which is our positive. So that completes our circuit. And what we have is 3 different resistor types. We have a 220 ohm, like we did with our calculation. Then we have a 1K, and then we have a 10K. So with each of these resistance comes greater reduction of our current, and because of that, when we power up this unit, and by the way, the power is coming from our Arduino Uno R3, and because there's a 5 volt connection goes to our red along the top here, and our ground GND or 0 volt will go to our blue that's connected along the bottom there, which is, or along the top, which is our 0 volt DC. So we plug this in, we power up our Arduino, and what you'll see is exactly what we expected. With the 220, you'll see that we have the most amount of current coming through, which has the light quite bright. In our calculation, we calculate 22 milliamps. Typically for these 5 millimeter LEDs, they take or can consume up to, or the maximum is usually 20, but our voltage is probably going to be around 4.7, 4.8 volts as opposed to 5, and the tolerance on the resistor. So we're going to be in around the 20 milliamps. So that's about the brightest that we can get for this LED. Then we have our next one, which is the 1K, and it's a little dimmer. And then we have dimmer still, which is the 10K. So that is our LEDs that we are brighting, and we have this hardwired. Now, if we go back and we take a look at the next item, you'll see that we also have a RGB, which is actually the red, green, blue LED. And what this is basically 3 different colors, being the red, blue, and the green, that we can have in our LED, one LED, and it will actually display any color that we want. So basically, this is what the symbol looks like for that unit. So again, it looks like 3 different ones, and you see this is the basic symbol right here of an LED. It shows like a diode, and it shows these arrows which would indicate the light coming off of that diode. So just like mixing paint, what we do is with our LED, depending on the intensity that we have for red, green, and blue, we can put any color together and have color showing up within our circuit to indicate to an operator what's happening. And we do that by using what's called a pulse width modulator. Now we can wire up the actual resistors like we've done for the original LEDs here. However, that would be very cumbersome. And so what we're going to do is create a program on our Arduino Uno that will actually use pulse width modulation. So every 1/500th of a second, it does a duty cycle, turns things on and off based on the amount of time that we want that output to be on for. And you can see here, it comes with a series of pulses. What that actually ends up doing is actually providing a certain power level to the output. So in this case here, we have 5% on, so it's 1 out of 25%. Next we have 50%, next we have 90%. So you can see how that is on and off. If we had 0, then no power would be provided to that output. So we can change the intensity using pulse width modulation. So let's now take a look at our actual sketch or program for this. And here we go. So what you'll see is we will move this over, and let's take a look at our actual unit a little closer up. There we go. And what we have is, again, you'll notice that just to reiterate, we have our 5-volt and our ground, which is connected to our terminal strip up here. Then we have our blue part of our RGB right here, and it's connected to the one side through a 220 ohm resistor. Then we have our red connected again through a 220 ohm resistor, and we have our green, which is also connected to the 220 ohm resistor to each of these leads. The one lead then goes back to ground. So that means that it is a cathode type RGB LED light. And then what we've done is we've taken an existing LED, just a plain one, and we've added a 120 volt resistor, or a 20 ohm resistor, and we've put that on output or pin number 9. And what you'll notice on these 9s and all these pins that we're using, we have this little tilde or the squiggly line, which indicates that they are pulse width modulated outputs for us. So our kit actually has 2 of these RGB lights that we can play with. So again, this is what the actual unit looks like with the 4 wires coming out of it. So we are all powered up here. And so let's look at the actual program. And you'll see the RGB is controlled again, like we said, by pins 3, 5, and 6. So 3 is my blue, green's 5, red is 6. Then the red LED that we have is connected to pin number 9. And that basically what we're going to do is we're going to mimic how much of that red intensity is there by seeing how much that red is going on and off as well. Then we have, once we've defined our pins, we do our setup. And so we indicate that both the red, the green, and the blue, and the red LED are all outputs devices. Then what we do is we determine whether they are on or high or off or low. So they're on or off, and in this case here we turn red on to start, we turn green off, blue off, and the red LED will also be off because it mimics the red. Then what we do is we define our variables. So we have integer variables, and for the red, the green, the blue, and the red LED value. So this is our main loop, and our main loop continuously cycles to create our program. So we define our delay time, which is 10 milliseconds, and our value that we can place on our output or analog output for pulse width modulated output, is 255. So we can go from 0 to 255, which is basically 0 represents everything's off. 255 represents full power to that output. So that's what we do. Then what we do is every 0.010 or 10 milliseconds, we increment or decrement one of those values. So in our case here, we're going to start with the red. It's fully on. Then what we're going to do is we're going to do a loop right here. And the loop is from 0 to 255. And so what we're going to do is we're going to fade out that red and we're going to bring the green into full. So our red value goes -1. So it's always going to decrement by 1, and our green value increments by 1, or the plus. Then what we do is we do our analog write instruction to actually write those values. So our red's going to be decreasing, our green's going to be increasing. So our red-green is going to have the same value as our red value. And then we do a delay time, which is the 10 milliseconds, and then we do it all over again. So that is our first loop that we go through. Then what we do is when at the end of that loop, we say our red value is 0, our green value is 255. So now our green is full intensity and our blue is 0. We then loop through that and we decrement our green and we increment our blue. So our red is 0. And again, it's the same type of thing. We keep on looping through this. Once we've done all 256 or 255 steps, then we go to our red value 0, green value 0, and blue value is 255. So this time what we're going to do is decrement our blue and increment our red. So if we go back to, so that's what we do here. And again, our red LED follows our red there. If we go back to where we looked at our color sequencing, so basically what we're doing is we are blending these colors together so that we can mimic exactly or similar to what we see here and get all the different colors that are possible within this RGB LED. Okay. So once that's finished or done, what we can do is we can click verify, and verify. What it will do is go through our program just to make sure that we have everything according to the values, and there's nothing, no syntax that are missed in our logic. And once that's all been verified and it's compiling, and again, our program is actually also called a sketch. Then what we can do is we can upload this to our Arduino Uno. There we go. So it's compiling and it's uploading it. And when it does, you'll see that now our program is running. And you can see how it goes through our different colors. And this light over here indicates how much red is within that color that we see here for our RGB. So you can see that's very interesting, and it's very great that we can actually change all these different colors and indicate to our operator exactly what colors we want. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.